bust out the Gonc.
Let's look at the integral and derivative definitions from test 1 of January 2015. So remember that integral is also the antiderivative. So what we're trying to look at here is the relationship between the derivative and the integral. So if we have a derivative, we can take the backwards derivative, get the integral. If we have the integral, we can take that out of the integral, and it is the derivative. So you may be asked to evaluate the integral. And if that's the case, then you actually do the integration. So you do the antiderivative. Here's an example. The integral from 0 to pi over 2 of 6 sine x dx. So here we're actually evaluating the integral. So we have to take the integral of this term, and that's negative cosine x. And we evaluate it from 0 to pi over 2. And that's equal to minus 6 times cosine of pi over 2 plus 6 times cosine of 0. So cosine pi over 2 is 0, cosine of 0 is 1, so we get 0 plus 6 equals 6. More complicated example, well, this one's pretty easy too. If we evaluate x squared plus 2x plus 1 and we want to know what the integral is, then we actually do the integral. So we get 1/3 x cubed plus x squared plus x evaluated from 0 to 3. So this simply equals 9 plus 9 plus 3, all minus 0, because all these zeros plug in here and make a 0, so we get an answer of 21. So if these are harder, remember you can always use int on your calculator if the integral over here is hard to do. So remember, you can always check to see if you've done it right by going backwards. So if you do the integral, you're asked to find the integral or the antiderivative, then just take your answer and find its derivative, and it should put you back here. So here was your answer, remember? This was the answer. If we go backwards and take the derivative, we should get the derivative of our answer is equal to whatever I just had in the integral sign. So remember, derivative and integrals has this relationship, so you can go back and forth. So we asked a lot of questions about that. So what if he was asking find dy dx? Then it's easy. You just take the function straight out of the integral, straight out of that integral sign. So for example, find dy dx of this expression here. It's in the integral, so this is the derivative right here. So we just grab it and take it out, and we plug in the limits of the integration. That's 0 and x here, so it's just a matter of substituting back in the x. So why? Because the integral of a derivative is the function, and the derivative of the function is the thing that goes into the integral. So there are trickier ones of this, remember. So, for example, what if we had the same function, but we had different limits, x squared going to 3x squared? So we're integrating for these limits, then we still plug it in, but we have to do the top and the bottom. We have to do it just like we were doing the integral, and we have to remember the dx term. So if we just take it over here and plug it in, we get 6 sine. Instead of x, we put in 3x squared. And then we do the dx part, which is 2x, because the derivative of 3x squared is 2x. And then we do minus 6 sine of x squared now. Plug that in, times the derivative, which is 2x. And then I just rearranged it and brought these things in front, because textbook seems to like the things in front of the sine and the cosine x. So don't forget the dx part on these ones whenever you have something complicated in these integrals up here, like so, or like so. So you'll notice that in the first one that was really easy, we could have done this. We talked about this before. We could have paid attention to the dx part there too. So we still do it. It's just that it was so easy that we skipped over it. but let's just do it here to show you that. So if we did the same one, find dy dx for 6 sine x going from 0 to x, then we say 6 sine x dx, but in this case we put an x in for the dx, minus 6 sine x d0, because we're putting the 0 in here, and dx, the derivative of x is 1, the derivative of 0 is 0, so we end up just with 6x, which is the same thing we had up here. So it does work out if you go through that, but it's pretty tedious, and you can kind of see that you don't need to really do it on the simple ones, but you do need to do it on these trickier ones. Okay, lastly, so if you're given a question that says, suppose that the integral of f of t dt is equal to some function, find f of x. So don't be confused by the fact that this is f of x and f of t. They have to use different variables, t and an x, when they're doing this. But you're basically just saying that if this is the integral out here, then this is the derivative of that function, because if I take the integral of a derivative, I get a function. So going backwards, I just take the derivative to get this value that's inside here. So we're going to just take the derivative of what they give us. So we take the derivative of this, and we get 2x plus 2. 2 times x, and then we just have the 2 from out front here. We get the 2, and we get the 2x. So in this case, we can go back and forth if we wanted to. So to get the derivative, which is the function in the integral sign, we take the derivative of the answer. If we want to check, we go back and take the antiderivative this way, and we should get the original function. So those are several different ways that you can talk about looking at the integral and the derivatives, how they go back and forth. That's it.